start in a couple of minutes. Actually, I'm waiting for the ones that are pretty late. Yeah, maybe I can start introducing myself. So I'm actually the VP of Security of Rocket Internet. Yeah. This way? Okay, good. So I'm actually working at Rocket Internet. Rocket Internet is a startup incubator, or also called the company builder. And we are actually in charge of launching companies all around the world, outside China and US. Before Rocket, I've been involved in Red Hat as a consultant, Bravofly, now called Last Minute Com Group, as system engineer, and Private Wave as system engineer as part of their mobile encryption platform. In Rocket, I've been starting at Rocket 4 years ago, well, 3.5 ago. Since a year and a half, I'm in charge of security worldwide. So talking about DevOps, for me, DevOps, apart of being a complete mess from a security standpoint, means a couple of things. First of all, DevOps for me means putting all the things together, so a kind of conveyor belt in an airport where all your luggages go through. Imagine that as a DevOps. I see DevOps as a starting point for putting all the components together in a way that you can deploy everything in the fastest way, in the most secure way possible, combining all the components together. Although that would be my dream, at the moment we are exposed to two main problems. So the first image you can see is actually what I live in. So everybody keeps saying to me that works fine in development in their laptops, and now it's an operations problem. They don't care about platform not going and not working on production because it was working on their laptop. And the second thing is that everybody wants to go full DevOps because DevOps nowadays is cool. Yeah, everybody wants to be DevOps. So every time there is a buzzword like DevOps, everybody wants to embrace it. But the problem causing that is that, yeah, I mean, with DevOps comes a lot of security together. And why security needs DevOps? In my opinion, DevOps, it's mostly, DevOps and security have to work together to solve 4 main issues. The first one is probably the most common one, configuration errors. We are not perfect, we make a lot of mistakes. So together with human mistakes, so bad operational security, those are 2 of the main things. And then, of course, nobody likes to patch systems. So, yeah, I mean, we love to put systems on the internet, we love to install machines and so on, but nobody likes to keep them updated. And last but not least, coding mistake. A lot of developers keep doing a lot of mistakes. Developers blame sysadmins that the infrastructure is not secure, scalable, and so on. Sysadmins blame developers saying that their code is shit. So we will never find kind of thing that works for both. So we at Rocket started actually with the very first task that was giving developers superpowers. We found out that we were completely wrong. Giving sudo access to developers was not the right way to provide DevOps methodology within the company. I mean, most of the time, developers are not exposed to system engineering. They don't have the background for that. So giving access to sudo, so kind of superpowers and so on, to developers just caused a lot of troubles and more downtimes. So that's my first experience when we embraced DevOps at the beginning. So yeah, everybody had the superpowers, and we learned the hard way that it doesn't scale and it doesn't work. So yeah, if you don't follow this user on Twitter, I really suggest you to do that today because it's probably the best thing on the internet. So I totally agree with this sentence. Once you are DevOps and once you do a lot of configuration management and so on, to propagate a lot of mistakes across a plethora of systems, it's pretty easy, and it's just a click away. So yeah, just follow DevOps Borat because every day you keep getting very cool stuff. So today we're going to talk about probably many of the technologies that you use on a daily basis. Do you recognize anything you do use on a daily basis? Like, who uses GitHub here? Okay, good. Who uses Git or Subversion or also Elasticsearch? So Memcache, AWS, Jenkins. Who uses Jenkins here? OK, yeah. OK, so starting with GitHub. GitHub, as you know, is a very cool platform from one point. It gives the chance to people to deploy their code and to share their code in the easiest possible way. But GitHub is also a search engine. Following the Google approach, with GitHub, you can search within projects, you can search within user repositories, and you can search within a lot of code base around the world. So the main problem with GitHub or Bitbucket is information leakage. A lot of things get exposed by mistake, on purpose, sometimes on purpose because people love to use GitHub to make personal backups because they think it's on the cloud, it's secure. Nothing can go wrong. But they are completely wrong, actually. If you try to look at one of those search queries on GitHub, you can see a lot of funny things like FTP server configuration. I mean, I was amazed by the fact that there are not just IPs, host names, username, and passwords on GitHub about FTP server, but that in 2015, people still use FTP. Another query that you can use is to extract certificates or private keys. Another one is that people love to make mail dumps of their marketing campaigns, for instance, over GitHub. So if you want free mail addresses to spam tomorrow, you just go on GitHub and you look for XLS mail and you see a full dump. If you want some customized, already prepared, full data MySQL dump, you just go to GitHub and you look for a MySQL dump. And you will see that a lot of companies love to make MySQL dumps over GitHub. If you're curious, and if you love PHP, like many of you probably, you can just go and search for PHP pages, PHP code base that contains a remote code execution with a function that could be preg replace. And for me, when it comes to GitHub, for instance, one of my teams at Rocket is in charge of pen testing. So we do a lot of penetration testing on-site and remote. And one of the first activities is to collect all the information about one company, so one of our company or external companies. And GitHub is one of the tools we use to collect all the information about that company. Who are the users, which code base, which platforms. You find a lot of things on GitHub. And most importantly, what GitHub marks as a feature, and for me it's a bug, but there's an ongoing fight that I will never win, it's that with GitHub, or in general with Git, people trust names, emails, and in the case of GitHub, people trust pictures. Every time you have a user account on GitHub, you might have either the user profile picture, or even though you might rely on Gravatar. So imagine the situation where I have a Git config with name, a random name, email, a random person, as you can see. Imagine that Linus Torvalds makes commit within my repository. And if you look at the face, it's the lovely face of Linus Torvalds. But Linus Torvalds will never commit to my swag.git repository. So the main problem about this is that when it comes to commits or pull requests, or in general code review, a lot of people trust just the pictures. We had situations in my company or also outside Rocket where, as part of our pen testing scans and pen testing activities, we were injecting malicious code into the main code base. We were always committing as the technical team lead or the super guru about that language, and nobody was even questioning or opening the code because that guy is perfect, can't make mistakes. We just trust him. So you can see within also your company that if you commit as probably your supervisor, nobody will ever question your supervisor code. I would start do that, to be honest. So I asked GitHub, what can we do about this? And GitHub, probably correct, probably not, just replied to me that it's not a bug, it's a feature. And yeah, I mean, they provide, as you can see, they say, this is a feature of GitHub that can be abused. And we take abuse very seriously. So every time you see a repository that doesn't match what should be in there, just notify them. So again, if you rely on GitHub, I suggest you to do a couple of things. One of the things is never trust the code committed by external peers, especially if they come from a pull request form. Just review the pull request, better if with a couple of eyes. Always delete private fork when somebody leaves the organization. So as you can see, people tend to join an organization, maybe they leave the company until July. That was fixed right away recently. Until July, if somebody left your company, the private fork updated to the main branch, and so the main repository would have stayed there and not deleted. So you had to remove that from the organization. And most importantly, GitHub supports multi-factor authentication. So try to use that and try to enable multi-factor authentication and force it across your whole organization. As you can see, auditing organization members that support or don't support multi-factor authentication is just one API call away. So when it comes to RCS, or revision control system tools, we have Git, we have SVN. When it comes to Git, I've seen who use deployment tools like Git. So who use Git for deploying? So like deploying code base. OK. I hope you are smarter than the things I've seen around, because many people, and I'll start with this picture. So round about 219,000 websites actually deploy with Git in the wrong way. They deploy in the document root by doing git clone. Wherever you do a git clone within a document root, you leave the .git folder in there. So a git clone is different than a git export. So the equivalent of an SVN export is not the git clone. Wherever I've seen around that people use Apache or Nginx and commit in there, and then do the clone in there, they leave everything you need to clone on your own, the repository. Now, people tend to fix it by turning off directory index on both Nginx and Apache, but that's not a fix, because you don't have to be a super hacker or whatever it is called to try to access .git within your document root. So every scanner, every security scanner like Nessus and so on do it, and most importantly, you have to rely on the fact that directory index in general is not security. So when it comes to, Git exposure, so wherever you expose a .git, you potentially, without knowing it, you also expose source code, certificates, MySQL dump, backups, your whole code base, API keys, and everything that belongs to your application. Most importantly, another interesting thing I've seen is that if you go also on GitHub or within your own company and you look for the first 10 commits in the whole repo, you can see that in the first 10 or 15 commits, there's everything. People committed by mistake passwords before adding git ignore. People think that the history deletes everything. So if it's in the history, it's no longer there. But the fact about GitHub is that you can go back and forth wherever you want. So if you by mistake commit password or an API key and so on, unless you want to rotate it, you have to go back to your repository in a proper way and cut off all the commits that might expose your data. Most importantly, if you look on Google, for instance, on .git entitled index off, that's the title name of the Git page, you can see that around about 219,000 websites are actually exposed on the internet, and you can clone them. So if you now go and you want to have some fun or you have nothing to do tonight, you can just go on Google, look at the websites. There are also some interesting things in there. And you can just keep cloning those websites in a very simple way. You just download everything, including the .git folder, and then you have your repo right away. So there is no need to do anything special. You just have the repo there. So you download everything and so on. So when directory index is off, so there is no way to understand if .git is in there, there are a couple of tools that comes handy, like gitffck just does brute force. So it tries to brute force for you all the objects within the Git folder and tries to map all the hashes together with your file names and try to rebuild for you the objects folder of Git. And I've seen also that people tend to make a lot of regex around the .git folder, making mistakes. So wherever you escape twice, the slash, for instance, you just bypass the regex. So .git//config works. And most importantly, Git stores an object folder whatever. In there are all the information within the object folder. So even though the repository is not complete, but you have the objects folder, you can still rebuild your repository. So let's say you have a list of hashes. So every file has a sha1 hash that you can retrieve with a simple command that is git cut file -p. And wherever you download all the hashes, you can just cut that specific hash and get the source code. Usually that comes handy when there is an incomplete repository or there is a corruption in the DB and you can't just do git log or git commit or git history because they say it's not a valid repository, although you have the full git objects folder. So you can remap every sha1 hash back to its source code, as simple as that. When it comes to Subversion, yeah, 1.6 was pretty easy to not even hack, but to access, because every file had a .entries file. When it came to 1.7, the developers of Subversion decided to, as you can see, to use SQLite. They thought SQLite was a layer of security. So they thought that by using SQLite, everybody probably would have hated that and not tried to exploit it. Unfortunately, Metasploit, it's one security framework commonly used, does provide you a very simple way to get the SQLite DB that it's called wc.db within that specific folder. And once you have the SQLite DB, you can launch a simple query and remap all the objects to their hashes. And even though you can download the same way as Git, you can keep downloading every entries file. So you can execute the first query against the whole DB, and it will extract the file name, the path, and the hashes. So it's very simple to just extract everything and get back the content of the files. When it comes to CI, I would say Jenkins is my nightmare. Jenkins is a very powerful tool. Everybody loves it for deployment. Everybody can deploy and build a lot of source code in a lot of languages. But that's the real problem of Jenkins. Jenkins does too many things. It's not the problem that it's written in Java, to be honest. But the problem is that it just does too many things. And in its core, Jenkins is a remote code execution tool. So whenever it comes to Jenkins, as you can see, there are a lot of plugins, around about 1,000 plugins that do mostly everything, really. And there are some security advisories over the years. There have been some advisories over the year. In the middle, like, I would say, 2014, the 14th of February, we had a very strange situation where in the credentials page of Jenkins, you would have seen the asterisk instead of the passwords, but if you just looked for the source code, you would have seen the password. So the input text of the field was the password itself. And the guy said, oh, I'm sorry, I didn't notice. But this kind of feature was on the internet for about probably 10 years, because it was derived from Hudson. And so yeah, Jenkins itself, it's a problem, but it's a problem in the way that it gets configured. So how many of you knows Shodan? Okay, Shodan is probably one of the best tools over the internet. It provides you a way to, Shodan scans for you the whole internet. It provides you fingerprinting of all the services around the world of exposed machines. So you can look for exposed services, HTTP headers, application headers, or just map specific ports, specific protocols to a country and see all the IPs that are exposed to the internet. So scanning the whole Jenkins around the internet provided me some open Jenkins, around about a few thousand, that can be exploited in multiple ways. You can exploit them in a way that you can enumerate all the Jenkins instances and provide operating system, user that runs for the Jenkins service, or also you can use the very powerful Jenkins script console that is written in Groovy. And the Jenkins Groovy script console, it's a very powerful tool. And if you're lucky, your Jenkins is gonna probably run as Jenkins user. But I've seen a lot of people who love to run services like Jenkins as root because it's cool. And the problem with that is that you just need one liner to cut, for instance. That was the user of my Jenkins, was called Batman. But in the Groovy console, you can execute that one liner to extract the SSH key. it's likely that if somebody exposes Jenkins, also SSH will be exposed. So wherever you cut the SSH key, for instance, if you prefer, and it's easier to manage that system from SSH, you can just take the key and connect to that machine with that SSH key. So the same, as I said, exploiting Jenkins, you start from the assumption that your guest authentication is disabled. In the case of the Jenkins scan made with Shodan, many people love to leave guest enabled. And wherever you can access a Jenkins project, so a Jenkins workspace, you have access to config files, sensitive data, credentials, API key. Given the fact that everybody now is mobile, you also have access to the signing key for Apple and Google Play. So that's one of the best parts, because I've been told that AWS config files get generated in a secure way. By secure way, many people out there think that it's because there is a dot before the file name. So I've been told that the dot between the file name makes the file secure. The problem with that is that, as you can see the config file, there's an AWS access key ID and AWS secret access key that provides you clear text and probably privileged accesses. They provide you clear text, passwords, and access key for Amazon services. That, together with the GitHub leakage we have seen before, makes life of attackers, of scanners easier. And that's why, and that's one of the reasons why many people found in their Amazon bills 7,000, 10,000 euros for Bitcoin mining. Because if you now look on GitHub for AKIA, you will see that you have a lot of free Amazon resources until you die. So you don't have to buy any Amazon service. You can just rely on the internal ones, on the free ones. Let's call them free ones. So when it comes to provisioning tools, either it's Puppet, Chef, Salt, or Ansible, you have multiple ways to secure your metadata, and most importantly, your access key, your secret key, and your API's keys. In the case of Puppet, there is Hiera-EYAML that provides you asymmetric cryptography, so asymmetric encryption of that file, so that if you leak the Puppet manifest, it's in this form. Every time there is the password defined, you just define the encrypted form of the passwords. So if this file that is usually going out and leaked goes out, you don't have to really mind, because the key itself is still on the Puppet master. So the key runs, every time Puppet runs on the Puppet master, on the fly, it encrypts and decrypts the file. The same with Chef. You have this so-called data bags. The data bags itself provide you a way to encrypt with a password or a certificate all the information, sensitive information that Chef provides as part of their recipes. And again, data bags works the same way as Puppet. So you put in there all sensitive data, and you rely on knife to open and lock the Chef repository, so the data bags also. When it comes to Vagrant, who uses Vagrant here? Okay, I think a lot of people. So Vagrant made not a mistake, but probably didn't think about it. When Vagrant was launched, all the new templates came from HashiCorp, the company behind Vagrant. Every template had the same key pair, SSH key pair. And that SSH key pair was actually even exposed on GitHub, so committed on GitHub as part of insecure key pair. So you would think that exposing the key pair, nobody would use it and would regenerate the host key. So I was curious, and I started scanning the internet for public IPs who use that key pair. And that's just a 24 class. And you can see that there was a company in China that was using the same private key as the one you can download it. This, together with the fact that by design, most of the people use Vagrant with sudo access without passwords, imagine what can happen. You have root access to all these machines because you can just do sudo -i or sudo su minus, and you can get root to the machines. And then you have a free cluster provided by Vagrant all around the world. Luckily, with 1.7, things got better. There was one developer that already mentioned this in a bug report that lasted for about a year. In the meantime, there was this Vagrant Rekey SSH plugin that just regenerated the host key every time you were spawning a new Vagrant machine. This came together and came along with Vagrant Core starting 1.7. So every time you launch a new Vagrant machine, it gets regenerated and then gets, basically, yeah, you have the new Vagrant machine that gets the new SSH key. One nasty thing you can do with Vagrant is that I've seen people mounting VirtualBox shared folders as part of their provisioning way of deploying code. So wherever they want to deploy code, they just mount a folder from VirtualBox and they map it to the Vagrant machine. So if you're a very bad person like me, you can just put something in the post commit of that Vagrant share folder. So imagine the share folder as a folder that gets deployed by Jenkins and with a Git clone. So I just wanted to have a persistent backup, or even better, a persistent backdoor within all the Vagrant machine of all my developers. And they found vagrant.git hooks post commit with an echo append to the authorized keys of SSH to be the best place. Every time they were destroying a container and running a Git, like Git clone, Git pull, and so on, I was automatically adding myself to the authorized keys of SSH of all those machines. So yeah, so my suggestion here is that I've seen people mounting blindly all shared folders. Try to see and try to check what's in there. Also, if you look on the internet for Vagrant passwords or in general machine passwords, Kickstart files, if you use Red Hat or CentOS or Fedora and so on, are pretty common. Kickstart files that are mostly template-based, that are used for deploying machines on Redis systems. You can encrypt the passwords by root password ---- is encrypted, but most of the people love to use root password ---- plain text. So wherever you scan the internet, again, for Vagrant templates, you can see that people even define, in the Anaconda Kickstart file, they define the password clear text. So yeah, I have to hurry up a bit. But when it comes to Elasticsearch, probably Elasticsearch is one of the worst things that you can expose on the internet. Elasticsearch, again, it's a full text search engine, but it's also a very powerful system and a very powerful code base that lets you do many, many things. One of the things we have learned the hard way is that Elasticsearch is one of the main vectors when it comes to Bitcoin miners or malware uploading in general. So I found a strange query on one of our systems that, I don't know if you can see it, but online you can see a wget -o TMP malware. That wasn't really a legitimate query I found in our logs. And this way, people injected a malware within the TMP folder of my machine. And with the second command from the Elasticsearch sandbox, they executed that malware. And they got local access to the machine via SSH. And after that, they were able to run a local exploit and escalate the privileges. So the main problem here was actually two things. One was that Elasticsearch up to 1.3 had the sandbox that was just letting you doing everything you wanted. And so their fix was to disable the dynamic sandbox on your YAML file starting 1.3.2, I think. But the other problem, and I think it's the main problem of every software still in 2015, is that people don't know what's the difference between binding services on localhost and binding services on all interfaces. I've seen that people say to me that 0000 looked better and was easier to understand than 127001 because then you cannot access it. So binding on localhost would have saved that. But in general, I mean, the default configuration usually of many services, of many also NoSQL databases, mount and bind on all interfaces. So again, if you want to run a very nasty query and you have the right privileges, you can also read inside etc. In the case of this query, it was just Elasticsearch user, so I could just read etc host and get a map of all the systems. And from Elasticsearch, I can run nmap, for instance, and scan the whole infrastructure underneath. And also etc password. And if it would be root, of course, you could get etc shadow and then easily crack all the hashes. When it comes to in-memory databases, I have examples for 2 DBs. One is Redis, that by default comes with the best thing up to now. No encrypted communication, no credentials, binds on all interfaces, finally fixed by our beloved Antirex, and actually runs on port 6379 on the internet. The problem with that is that as of today, there is just a way to authenticate with user and password some operations, but there is no authentication layer behind. Again, you can use Shodan for scanning Redis instances, and you can find thousands of Redis instances. And once you found Redis instances, you would think about what people can put on Redis that might harm me or affect me in a way that. So I can tell you that people love to put email addresses when it comes to marketing campaign. People love to expose and share the session, so the cookies of all the users. That was an e-commerce that was sharing to third party for making kind of landing pages without having to re-authenticate. They were just exposing all the cookie, all the session of all the people on a Redis exposed on the internet. I can tell you that if you take that session without the proper definition of cookie, domain, and path, you can reuse that cookie to go right away to the checkout of that user and buy as that user. And most importantly, people love to put customer tables, let's call them customer tables, in customer namespaces. And you can see that people use email and the super secure MD5. Of course, I'm joking, but people still use MD5 these days. And that DB was of an e-commerce in China as well. And that e-commerce had about thousands of passwords that you can probably crypt within a couple of hours. And the same applies for, again, if you're a bad person, very bored, you can also make some damages. Think about most of the people don't make backups on Redis. So they have probably every key is not backed up and every key is on Redis. So think about running a flush hole and cleaning up all their key spaces. So you just remove all the keys from all the databases. It might be that people don't know how to recover the keys. So everything you put on Redis is lost. Luckily, still people probably run cron script or kind of queues that import into Redis from MySQL or a Postgres. So you might still, but it still will take time for you. And again, there's also a lot, again, of bored people that run a very cool idea of clustering open Redis machines for performing cracking of passwords. So there's this guy that runs Redis SHA crack. And this tool, basically, you just have to provide all the IPs of the Redis instances exposed on the internet. And that tool, because of the Redis Lua sandbox that is very powerful, we take care of aggregating all the machines as a cluster and using the machines to compute hashes and try to crack those hashes and giving you back the passwords. So it's a very nice way of distributed system for free. So again, for Memcache, it applies the same things. It's because of a firewall missing. It's about wrong definition of firewall rules, and in general, running it as root is very bad, but also binding it to all interfaces is very bad. When it comes to Memcache, I still have no answer about this. I found a Memcache instance on the internet that had one private key in there. I don't know still why. I mean, I know why, because there was a company that was having their LDAP user directory tree, and they were generating for the people the SSH private keys. So they found that exposing all the SSH private keys of the users and giving them to the developers, probably plain text via email, was a very smart idea. And yeah, so you can probably still find it online, and you have around about 2,000 SSH private keys. Another interesting thing was a Russian provider that thought to put all username and passwords of their Plesk-like interface, plain text, in the Memcache table. Last but not least, Docker. Docker is cool these days. Everybody wants to use Docker. Everybody's probably using Docker by now. And one of the best use cases I've seen is that people mount /var because of MySQL and because of Postgres database. So whenever you mount /var, you have access to the MySQL DB or the Postgres DB. On the other hand, mounting /var without limiting it to valid MySQL or valid Postgres exposed the Docker socket. The Docker socket has to run really high privileged, as root and Docker because of the API calls you use within Docker. So by mounting this way, for instance, I expose the Docker socket within my container. And doing this, so mounting the Docker socket within my container and within my guest makes it pretty easy to take over the host that hosts the guest, and I can take over and write to my host just by mounting it. So imagine a situation where you have a Docker container spawned up on a Docker guest, and from that container, you install Docker, because why not? So you install Docker within the Docker container. I can tell you that, I don't know if it works, yeah, okay. So it's pretty easy to understand, but if you create a container, and then inside that container, you install Docker, and you mount another container by exposing the host partition that was belonging to the host within the machine, you will see that you can write to the host directly. And that's not the idea behind Docker. The idea behind Docker is that it's a sandbox, it's a container, and you can't write outside of it. The problem with that is that you can still install Docker in a container, as I said. So by installing Docker within the container, you will see now that Docker will run, and it's speeded up. So now I mount a second container from that container. It's kind of inception of containers, but it explains pretty well what's the risk in exposing the socket to all the hosts and to all the guests, I'm sorry. And so by doing so, you can basically access every single file within the root file system, within the host file system. And just imagine adding yourself on the host etc passwd and etc shadow, or creating yourself a user. And we identified this in a French hosting provider that was providing Docker machines to many customers, and was just was just providing you a PHP control panel where you could have mounted resources. But they didn't filter out / or /var, for instance. So we just tried to mount /var within our container, and what we got, to be honest with you, was around about 2,000 Docker containers for many customers that could have been accessed from that guest I bought for a few euros. So you can see that I got full access to the container and I'm fully root. So it's very important actually to make sure that you don't expose. You can write as many things because you are actually writing on the, also systemctl runs if you use systemd, you have the right C groups. So you can just make sure that if your socket file is exposed, your whole machine can be compromised. Just last week at DockerCon in Barcelona, Docker developers and Docker security team announced a few ways Docker machine, together with Docker APIs protection and better sandbox of some API calls, they will improve this part. But for the time being, please just don't expose the Docker socket, because it's really, really, really a chaos, and it's not security and makes a lot of damages. So again, as a security team, actually, just to complete this, we were trying to be on the conservative side to say everything that is new doesn't belong to us, we don't want to help. But we found out that it doesn't work like this. So we just have to embrace this DevOps methodology and work together on this. So at least from my side, as a security team, we started developing tools, auditing scripts, and so on, to monitor and to improve automatically and manually whatever people do on the systems. So either with the cloud or bare metal internal clouds and so on, you can still monitor a lot of the DevOps things that people will run across your organization. Yeah, again, DevOps is cool when it comes to patching. So providing some auditing scripts to your companies and to your team members gives the possibility to improve the patching management system and processes across the whole organization. So I think DevOps has pros and cons, and you just have to use them in the proper way. That's all from my side. Thank you very much.